a presentation from Alan's got a new toy. So it'll be interesting to see how that works.
Yeah, if I can even get it to do anything. I froze up my camera here. Hold on a second. There we go. I'm back. This is more just a fun discussion starter here. I don't really have a huge thing going on. So let me just give me a second here. Let me pull this up. Oh yeah. So I got the, I think if I do it this way, can you see this? The Intel RealSense P435.
Yep.
Okay, let me get the window so I can see what I'm showing you here. Okay, there we go. And right now, got it hooked up to my laptop, and I'm just going to set it down here to the side. And this is just the starter script. Wrong page. Or wrong file. Let me go over here. There we go. So this is just using Python just to capture. So it's a depth image. The color is based on the depth or the distance away from the camera. And down here on the bottom, I just captured the average. And I'm not sure that this is in centimeters or meters or millimeters or whatever it is. I'm not entirely sure what the measurement is yet because it seems a little funny. But if I put my hands up to it, you can see that on average, the distance is a lot less. If I back away, it gets in. If I step out of the way completely, shine it on the wall, it gets to be about 1,000. So anyway, that's one little piece of fun. Just very, very basic. Yeah.
Is it taking the average of the image, or is it like what is the distance?
Yeah, I just took right here. I took the depth image. It's a NumPy array. So NP is if I go up here, import NumPy as a NumPy array, or for a NumPy array, and then the depth image is just taking the color depth frames data and putting it into an array. And then I just took that array and calculated a mean on it. Just so I could show that, you know, it's calculating distance for tonight. That was real basic.
It's still pretty cool that you can plug it in and get data out of it.
Yes, it is. And then let me see if I share this here. This is the viewer program that comes with. You can just download this. And so you can see the 3D space. Let me move this out of the way. And then if I turn it on, several different modules here. And right now I have the RGB color turned on and the, I guess that's, I'm not sure what the stereo piece is doing.
But do you get a RGB depth image?
Yeah, so this is an RGB depth image right here, and you can see it's in 3D. And it can't see what's behind me, so it blacks that out, right? The camera is right here in front pointing backwards. But you can rotate this around in 3D. So that's pretty cool.
Yeah.
Is this the one with an accelerometer as well? So
It is, yes.
okay.
So let me go here to, it says 2D. And then let's turn this on. Well, you can tell I'm not very familiar with this yet. Earlier I was seeing, there's a little accelerometer off to the side here, so you can see where it's at. But anyway, not sure why that's not showing up. And
For
then,
example,
oh,
sorry
go
to
ahead.
interrupt. Can
Yeah,
you
go ahead.
go into 3D mode?
Sure.
And then can you move the actual camera? Okay. That didn't do what I thought it would do. Because I was hoping it would keep you in the same space and then add more data behind you.
Yeah, like build my 3D shape.
Yeah.
Yeah, that it doesn't do that out of the box.
But I'm sure, yeah. Okay, cool. Thanks.
But still, yeah, that's that would be really cool to do. One thing I'm really really liking this, and I do think it tends to be, even though it's a 3D image, there are a lot of holes in it, like this whole area around the back of my head, because my head is blocking that. So there's always going to be these dark spots. And if you put your hand up, you know, like right now, my hand is blocking my entire head. So images in the near, close to the camera tend to block. Like if I hold up a pen, you know, it wipes out everything behind because of the, it's an occlusion, right? It blocks the camera's view. So I think it'd be nice to have a couple cameras coming from multiple angles so that you'd always be able to tell, like, at what depth is my nose, for example. If you had two cameras, you could have one be blocked, but then the other camera would still pick it up. And then if that, whatever was in the foreground moved, then the other camera would take its place. But you can see right here next to the cursor, like the distance is, actually, let me go to the wall. Let me get out of the way a little bit here. Do this against the wall. If I get the camera. So if I just set that there, the camera is stationary and the wall is stationary. So it's 1.42 meters. So that's 42 centimeters and change. So it's within a centimeter. So that's, we're talking a very, very small, centimeters about that far. So it's measuring that wall consistently to within 1 centimeter of distance, which I think is pretty impressive.
Yeah, there's not a lot of texture on that wall or colors or different shapes for it to pick up.
Yeah, and I'm on the corner there, but if I just move it over here, it's, you know, it's bouncing around a little bit, but that's less than a, you know, the average is probably, or the one standard deviation is, looks like less than a half a centimeter, which is pretty impressive.
Yeah.
I think if I do this, if I put my hand, if I get it to the right spot, see, then it'll change. And I won't be able to hold my hand. There'll be more motion in my hand moving around than there is in the error in the camera. Then I take it back out. And so the first thing I showed, the NumPy array that was being calculated or brought back into Python, is a 480 by 640 array, and every single one of those points, so 640 across and 480 up and down, has a measurement coming back on it. So every pixel on here that has a measurement will be in that array. I was just looking to see what these, there's actually three numbers here, 0.34, negative, what, 2.7, and 1 point something meters. I don't know what those other, the first two numbers, I'm not sure what those represent yet. So anyway, that was all I had for tonight. I just got this and messed around with it a little bit, and I've got a YouTube video here that shows using a point cloud SLAM demo that is really cool too. I'll share that. I got to find it first, so I'll share that here in 20 minutes or something.
Okay. I've ran that the RealSense ROS drivers on Kinetic and Melodic, and they both work.
That's pretty cool. All right, I'm going to pause this and turn this off.
Looks great. Really impressive.
It was easy too. It was pretty much very, very easy to get started.
That's what we like to hear. That's cool. Any, you're working on any projects?
Am I? No. Still, well, that's not entirely true. I guess a few weeks ago I was describing my my push to get waypoint missions in behavior tree format so I can show it off. And you know, I think I talked about this, but essentially what I'm going to do is set up a ROS service. So the behavior tree would feed GPS coordinates in decimal degrees to this ROS service. ROS service would spit out a map pose, or a pose stamped in the map of your choosing. And I think that's going to be pretty cool, pretty reusable, because it seems like everyone here likes to have waypoints in terms of decimal degrees. And if you initialize the origin and if you give it a map, it will spit out a pose stamped. And so that way we can, you know, a user can write down the decimal degrees, get pose stamped, have the robot go there using my previous behavior tree stuff that I've already done.
That's cool. There is like a origin server from Swirry that kind of loads up different origins. I think it's part of MapViz.
Okay, yeah, it does the WS84 projection for you.
Yep.
Does it? So it's a server that I can give it decimal degrees, and am I duplicating their work? Is what you're telling me?
No, for the
Okay.
origin to load your origin and keep track of your origin. I guess it wouldn't matter. I sometimes hard code that, but they use a little bit different setup.
Okay, I have it set up as a ROS param.
Oh, perfect.
So you can launch it off, and you know your ROS param will be different than Alan's ROS param.
Awesome. It's better than hard coding it.
But hard coding it, because when you go and load it onto your robot and it doesn't work, you're like, what's going on? And turns out it's hard coded to Alan's coordinates.
Yeah, it'll take a little while to debug.
So yeah, other than that, oh no, my video disappeared. Other than that, no, still chugging along as I have time.
Yep. I was working on the GPS, trying to get my base station surveyed in, and I was playing around a little bit with that. The default on that F9P from ArdrewSimple is 2.5 meters, and I changed it to 0.5 meters, and it took about 25 minutes to converge under 0.5 meters. And then I ran another test, which I'm currently still running. I put in 0.1 meters, Um, but it's been running maybe 7.5 hours. This number is really hard to see, but it's right now it says it's 0.7. It did get all the way down to 0.17, so it was about 17 centimeters, but then the air started to grow and now it's shrinking back in. So
Is the
I need,
plot in the bottom center your air?
uh,
That one.
yeah,
No, to the right.
this one isn't, I don't have a way to plot the standard deviation error. I'd like to plot that. And so what this is just the latitude, how one of the latitude is changing over time. But this deviation map in the lower left-hand corner kind of, this outside ring is 3 meters. And so you can see how it's collecting points, maybe to 2 meters or something, a little bit out here, 2.5 meters. But I don't know, I guess I'm just going to let it run overnight and see if it can converge down to 10 centimeters. And so then the next test I was going to do is, I don't know if this is right or not, but I was going to compare the base station lat long coordinates once it converges with 2.5 with 0.5 and then 0.1 if it ever converges, and see how much the distance changes. And then if I can get that working, then get the rover GPS set up. And then once it gets RTK, compare, like if it converges at 2.5 meters, what does my rover position say? And then 0.5 meters, what does my rover say? And to try to get an idea of an estimate of error. Jeff has done a lot of work with that GPS. I don't know if you have surveyed in the base station and got a feel for kind of the air around that.
I can't tell you right offhand. I think when I was playing with it, I had hooked to an antenna on top of the roof at work. I just let it run until it gets, the number got smaller, but I didn't really need it at the time, so I didn't look at it real hard. So I don't know what the answer to that is.
Okay. I didn't know how much air would be introduced if we leave it at the default of 2.5 meters or not, but hopefully here in a couple days I could have some data.
So once it converges at whatever your given standard deviation is, that standard deviation is going to blow right up, right? If you move your robot a meter in front, isn't that going to throw off that number?
Well, this is the base station. So your base station is stationary.
It's the base station part of your RTK.
Yep.
I understand. Stupid question.
No, it's a little weird because it will continue to move, like you saw on that, on the U center. You know, it is moving. It's being reported moving, and then eventually it'll come up with this whatever that number is in the center. But I'm not sure over time as this is moving around what happens to the the rover side of it. It's kind of interesting to. It's like if you really want to get accurate, it takes a little bit more.
So then you'll save that. Once it gets surveyed in, you'll save that, and then you'll be able to do a warm boot next time, right? Yeah.
Yep.
Yep. And then it'll remember where it's at.
Yeah, there's a couple different settings in the U center. You can tell it to survey in or tell it to go off the coordinates. So once you do the survey in, then you record your position, and then that's what you use for your fixed position.
Because really the whole point of that is, so wherever your antenna is, it has a real GPS coordinate. You just don't know what that real GPS coordinate is. And so I'll just use instead of trying to use lat longs, I'll just say if it was at point 100 and 100, so lat long of 100 and 100, if you knew that's exactly where you had staked your antenna, then you'd just go to your program and key that in, right? You wouldn't have to do the survey in. The survey in is attempting to find out that, oh yeah, my antenna is actually at point 100, 100. Am I thinking
Exactly.
about that right? Okay, yeah.
Yeah, totally accurate. You know, like every township across America has a brass cap, and that brass cap has the Latin long. And so you know that that's a surveyed position. So that's an example of an external verification of where you are.
So if you knew how to measure from that point to where your antenna is, then you wouldn't have to do survey in. You could just tell it, boom, here's where I am.
Yeah, for example, on your base station, you could set it up right over that cap, type in the lat long, and then send RTK corrections to your rover to your new base position. And then once you put that there, then you know the coordinates of your base station, and then move your base station over. Kind of leapfrog it.
Right, interesting, yeah.
Typically, how far does your base station and your rover have to be? Like, I'm assuming there's some limit to where you lose
the
whole
Earth
point of
is
doing
round.
RTK.
Yeah. I heard 10 kilometers. And I don't know what the air starts to get out at those positions, but I heard 10, you want to have your base station within 10 kilometers of your rover for corrections.
But theoretically, I could have like my base station at some headquarters, and down the road, okay, well, I don't have to describe what 10 kilometers is, but that's pretty big.
Yeah, pretty good area. Yeah, if you're moving from field to field, generally what you want to do is put in a fixed position, like a post or something that you can go back and mount your antenna to. So you always know that position as you're moving.
And can multiple rovers use one base station?
Yep.
Okay, that's useful.
Yep. Or if you're in a state like Jeffson, they broadcast the correction data, which is really nice. And you can even get in some farming communities, they'll put up base stations and then you can get local RTK. In Utah, in the valley I was in, they did that. And so you could use that.
And you can buy it from Trimble and John Deere. They'll sell it to you.
Yeah.
For a lot of money.
Yeah, I think it's about $2,000 a year for OmniStar. 2-inch. I think it's 2 inches.
And the funny thing is that's cheap compared to what it was 10 years ago.
Right. Yeah. Phenomenal.
So $2,000 a year. What does that, like, what work are they doing to get you that data?
Well, with OmniStar, you get your corrections from the satellite. And so that's pretty nice. Gives you some freedom and mobility. But some states, like, you can just get it over the internet. And so you can use like a cellular card, and then but cell service is not available in a lot of farming areas. So, and OmniStar does not work everywhere either. I did a lot of testing with it and it was great. And then I went out to a farm in Texas and could not get it to converge. Even at 8 inches, couldn't get it to converge. So it's kind of weird, but there's so many like little edge cases that you have to like have a lot of different, there's different setups depending on where you're running and what you're doing.
So it seems like you almost need to evaluate a different solution per geographic region.
Man, it can feel that way from place to place.
And we're just talking within the United States, and wow.
Right.
Okay.
Right. gets complicated. But you've got now well, I shouldn't say now, but we will have ubiquitous internet connection through satellite. So Starlink is going to be up, and that should give you a lot more options and more stability from region to region, or Project Loon. Yeah, the other
I
thing
give
is,
it. Oh, I say I'd still give it like 5 years.
give it a little time to work out the bugs. I mean, the technology is changing so fast that like you have to continually look and say, okay, what's available today, and what's, just because that's the way it was 2 years ago doesn't mean it's the way it is now.
I'm hoping the new GPS-3 satellites improve this stuff greatly. I don't know if they will or not, but they've only got 3 satellites up now, so for them to get up 10 to 20 satellites to be usable, it's going to take, again, it's going to take several years probably to do all that. So just eventually it'll come along, and then we'll see if it works.
And will we need to have the RTK, or can you just use a standard, just one?
I don't know. The only thing I know about it is they're going to have more powerful transmitters on the satellites, and they actually put a retro reflector on the bottom of the satellite. So as it goes over, they fire up a laser, and they can precisely measure its orbit, so they know how far away it is. So that it just makes their calculations better. And I'm sure with every generation they come up with a better clock on the thing. They got these like atomic clocks running, and I'm sure every generation gets more accurate on that. And I don't know. I think it's supposed to be compatible with the current system, but so I think right now, probably if you turn your thing on, you could probably see those satellites, and you may or may not be picking them up. But as I say, with only 3 up there so far, I don't know how much that would improve what you're getting. Or if you knew which ones they are, you could turn off everything else except those and see if it'll lock on and give you any data on that. So I just noticed they'd launched them, and so they launched the last one, a month or so ago. And I don't know if they're going to launch them once a month, or it'll be another 6 months before they launch one. So that's just something else that's going to come along one of these days that maybe that will improve things.
I think Elon was launching like 60 satellites at a time. Give it to him.
He's also got little tiny ones that he's doing. I think the GPS satellite is about the size of a bus. It's just this huge thing that they're putting up there. So but I don't know that much about it. If you go to GPS World, gpsworld.com, they'll probably tell you. Yeah, they'll either tell you about it or give you a link to go track it down.
Improvements are coming.
So, this might be a dumb question. I'm not very familiar with RTK. So I guess the question is, why don't I need RTK on my phone? Is it because they are using sensor fusion and integrating all my accelerometer data as well?
How accurate are you trying to be? So if you're trying to be within a 2 centimeter radius, your phone won't be that accurate.
Of course.
So I don't know what the range on accuracy on a phone is, but I'm guessing it's in, probably just go look it up. It's in the well over a meter of, it might know you're in your backyard, or it might know you're within I don't know. Somebody probably can find out what the range on a cell phone is, but it's.
Sure, like it'll tell me that I'm on the right side of a highway, but it won't tell me which lane I'm in, basically.
Or if it's within a lane, maybe you've got standard deviations like this versus with RTK you're trying to get a standard deviation of plus or minus a couple centimeters.
Plus, depending on what you're doing, they may be doing calculations you're not aware of. Say if you're driving down the road with your phone, it says, oh, he's going this way. He must be in the middle of his lane over here. And in reality, if you're driving on a road that's running parallel to it, you may actually be off by 20 or 30 feet, and it automatically locks onto where it thinks you should be. So they can do tricks like that too. So if you're just looking at the numbers, the numbers may not be as accurate as what it looks like on your screen. So that's
basically what you're referring to is like they'll snap me to a road because they know I'm not
Right.
likely driving
Right.
60 miles an hour off the shoulder.
Yeah.
It's like if you're driving down the road and you go to get off on an exit ramp, it says you're still going straight where you're halfway off the ramp, and then all of a sudden it'll snap over to where you're at on the exit ramp because it says, "Oh, the error must not be as bad as we thought it was." So it'll catch up to you.
Okay. So here comes the flip side of that question. Why do we in the farming community need 2 centimeter level accuracy for our robots?
It depends what you're doing. If you're trying to plant corn in a straight row, you want to have a straight row. And then Kyler claims you can come back next year and put the tractor in the same spot and it'll follow exactly on that line. And that's why you need the high accuracy, because if you're trying to duplicate something or you're just simply trying to go in a straight line, you need the higher accuracy. Now, if your application doesn't need that, say you can plant your corn once it comes up, once you can see the corn, you can use cameras to know where the row is and you can follow that way. You don't need any GPS other than when you get to the end of the row, it'd be good to know that. But so it just all depends on what you're trying to do.
Because in my mind, you need GPS to know whether you're at the end of the road. So why do you need to be able to come back next year and go in that same straight line and plant corn within 2 centimeter accuracy to the same spot you did last year?
Well, let me rephrase that. Instead of the
Okay.
next year, say you plant in the spring and in the fall you want to go harvest. So you want to drive down the same road to pick the corn. So the corn's already there, but you need to know where it is. So you can use a camera or you can use GPS. And the GPS will, if it's accurate enough, you can drive down the same row and
Yeah.
it just automatically knows where it's at.
So if your corn stalk is about this big, your corn stalk can be just a little bit bigger than this. And if you got a combine that you want to drive down that row to pick your corn, Jeff's right. I mean, you have other sensors that can tell where that stalk is as well. But your corn stalk, you're not going to want to be off here if you're going to use GPS. And then if they plant on 15-inch rows, they might, I'm assuming they stagger every other year so they don't plant right where the stalk was the prior year, but maybe they stay on the same spot. I don't know exactly how they do it, but they want to be either right on the same spot or else they want to be 7 inches over. So, plus or minus 2 centimeters maybe isn't entirely needed for that, but fairly close. For what I'm doing in the vegetable crops, I want to know where every single plant is so I can know, I planted a plant here and everything else that's not that plant is a weed. So I'm going to know my plant is within this very small spot. So I have a plant 4 centimeters over. I don't have to try to do visual, some kind of automated visual, a neural network or something to figure out that, oh, this is a weed. I only have to figure out right around that, within that 2 centimeter spot, this is a good plant, this is a bad plant.
So what I'm hearing is it's easier to throw a little bit more money at your localization sensors than throw time and money into your perception, because you're likely to get better results by upping your localization rather than upping your perception.
That's a good
Did I
good
capture that?
question. That's a good question. I don't want to say that I know the answer to that. That's a good question.
So another problem you have, say once you plant something, if you're putting down corn, you put it in rows that are like 15 to 18 inches apart. And when the corn pops up, you get these tiny little plants coming up, but you come back 3 months later to harvest the thing, the corn is now 10 feet tall. It's all branched out. It just looks like a carpet out in front of you. So you can't necessarily tell where the rows are by looking at it from the top. So now you'd have to have a camera down at the ground level. You could do that. That'd be another option on that. So if you've got cameras down low that can see the stalk coming up out of the ground, you could follow that. That might be another way to do it. Another thing that Kyler keeps pointing out, trying to drive straight down the field, he says rather than trying to use an IMU, he likes to use the dual antenna GPS. So he wants 2 accurate GPS receivers, and you measure the angle between the 2, and that way that'll give you a straight line. So you don't necessarily have to know exactly where you are, but you want to know the angle between the 2 so you can drive in a straight line. So you can just substitute, instead of using the heading from the IMU, you can use the heading directly off your GPS that way. And actually you can use a single GPS, it'll calculate the heading for you. But if you have two antennas, then you get a static heading. So if you come to a complete stop, it still knows what the angle between those two is. And if you just have a single one, you have to start moving at some speed before it will calculate that and give you that information out. So it's just lots of different things you throw at it here. And, you know, again, depending on what your application is, and if you got really cheap sensors that work really well, you put a lot of them on there, you don't have to worry about any of this stuff. But sometimes it's just easier to spend a lot of money on a GPS system to put on there, and it might give you better results. Of course, then you got the drawback, you get close to the trees and it doesn't work. And if you're driving, say, in a vineyard and you got things growing over the top, so you get a canopy, you can't see the sky anymore. So it's just always something. There's always problems there.
Yeah, I heard like the visual systems are getting a lot better. I heard Google, this is years ago, but they focused on cameras, and in their on-road vehicles, it's difficult to use a GPS because you're around tall buildings, you're going underneath bridges, and so there's a lot of occlusion. But years ago, they were getting 11 centimeter accuracy just with high resolution images and cameras. So it's really interesting. And even on those combines, they have like these little like little metal sensors that feel the corn row. So it kind of bends them back, and then they'll know if it's hitting this, like a curb finder, you know. There's a really low cost sensor to feel the corn stalks as it's driving through. But localization, I think, is hard just because there's just not one sensor that will solve every single problem. But cameras are getting extremely good.
Elon Musk would agree with you that you should go with visual.
I think they're using 8.
Yeah. He says everything else is a crutch.
Yeah. You hear the size of his computer that's in his cars now?
Yeah.
Yeah. So a lot of the self-driving car companies are using it. This is years ago, old data, but the Drive PX from NVIDIA was about equivalent to 150 MacBook Pros. And so that's pretty good size, pretty good processing power, around $10,000, I think, when it came out. But Tesla made their own computer, and it's, I think, 10 times more powerful than that. So, I mean, just massive power. But you can do that now. So crunching video data is possible now.
I'd also like to hear reports back on how well cameras work, simply because no matter where you mount it, it's going to get dirty, it's going to get muddy. If it's up above looking down, as I say, you just see the canopy at the top of everything. You can't tell where the rows are. So you've got problems like that no matter what you do. And anything on robots, it turns out every sensor you have wants to be above everything and nothing in front of it. Well, then you've got 10 sensors that want to be above everything and put nothing in front of it. So that's yet another problem you run into. So you just have to kind of pick and choose and say, can I put a camera here? Is it going to work? Can I put one here? And the GPS has to be above everything so it can see the clear view of the sky. So it's just more problems like that, trying to figure out where to mount everything.
Just wait till you're driving through a dry field and it's all dusty and the wind blows.
Yeah, in the middle of that dry field, here comes a Tesla screaming through, using its vision and high-powered computers and plowing up the field. And your camera like, damn, I look like a Tesla.
So if you opt to spend more money on your visual system rather than a localization system, how do you solve the issue of getting enough training data, right? Enough in different lighting conditions and different use cases. How do you get the labor for someone to sit down and train on, label that data? Sorry. And these might be very broad philosophical questions.
Those are, yeah, there are some augmentation techniques or you can do some things. You can do some data data side things, but you're gonna have to get some images from the field, and then what's the real truth of a picture? You know, you're gonna have to have somebody label those images so that they're what you want.
Another way is to use other sensors on your vehicle. That's, say if you're trying to follow a row, so you want it to identify the row, have the other sensors saying, yep, here's what a row is. So it's labeling it for the vision system so it can tell it, are you correct or not? So that way, you know, using the two sensors together, knowing you're done, you can take off the one set of sensors if you don't need them anymore. Or you might be able to have some kind of just a simplistic, say, image processing, simplistic identification system that says, yeah, that's a row. So it tells the sophisticated system says, yes, you're right or you're wrong when it's trying to decide on that. So there's probably different ways to get around that.
That's why I do kind of like the RealSense or even LiDAR type solutions. And I know LiDAR might not work for the type of fields you guys are driving through, but if you get depth for like a row, right? You know that this looks like a wall, this looks like a wall. So, you know, you don't necessarily need a neural net for that, right? You can just do clustering.
Like a histogram.
Right.
Yeah.
So, you know, the guy I'm working with that helped write a lot of the software I'm using, Uthika, he's from, and it just went over my head, I just spaced it, the name of the country, Sri Lanka. Okay, and he's been working on a grant, and he wants to write a white paper on machine learning and ROS and in farm type situation. And so anyway, we're going to kind of work together on that this summer and fall. So but I think at least for me, the hard part is defining it narrow enough without getting so narrow that it's not, you know, usable in a broader context. So I don't want to solve everything with machine learning, but I want it, so it's got to be specific enough. But then if you get too narrow, then it's just going to be useful for one thing and nobody else can use it. So trying to figure out how to word the problem that we're going to work on and then how we're going to solve it. So we're going to collect a bunch of images, I would imagine, a bunch of other sensor data, and then put it through some kind of an algorithm and do a write-up on that. And so if you know of any grant money, or if you want to partner on it, anybody wants to partner on it, we'd love to talk about that too. Let me share I found the video. It's actually a video, not a YouTube. So let me just share this. It's really relevant to what we're talking about. So this is he's got the software written and he had it running on his machine, but he's still working on the write-up on how to get everything installed so that I can run it. But this is, so it's a camera, right? A point cloud with a depth camera. So it's building a point cloud of everything in that room as it's driving around.
Is it drawing a heart?
I'm sorry, say that again.
Yeah, I was saying is he drawing a heart there, like it's a heart shape.
Oh, sure. Yeah, right.
So is it using machine learning to determine the points for the point cloud?
No, I don't think so. Mm-mm.
Do you know what a package he's using for that?
No, not yet. He shared a few different things, but I don't remember what it is. I can go look and see if I can figure it out.
Is that what that VIO is over there on the left? Is that visual
Yeah.
odometry or something?
Right. Yeah, that's kind of the concept. And there's probably multiple packages out there for that.
And so, just so I understand, this is only using the image data to build this pose estimate. It's not using any sensors, inertial or wheel odometry or otherwise.
No, I think it might be using other things.
Oh, okay.
Yeah, I wouldn't, it might be using just visual, but I think it's using other things. At least when we put it on my rover, we're going to use other things. We're going to use the wheel positions. We're going to use, I'm starting to understand GPS a little bit. I was going to say we're going to use GPS, but I'm not sure about GPS. But we're going to use an IMU. We're going to use the wheel positions and then the cameras. And I don't know if we need LiDAR. I think the camera does a pretty good job. So I don't know that we need LiDAR in addition to all of that, but we had talked about it.
The camera is probably an order of magnitude cheaper.
Yeah, it was $230 or something.
Okay, yeah. And even though the VLP16, they've discounted it quite a bit since it came out, I think it's still like $2K.
And is that just one
No,
point, or is that a field?
VLP's 16 lasers, so it gives you like a field, yeah, 360 or very close to it. I don't remember at this point.
Yeah, this, you know, the RealSense camera doesn't have a huge field of view. It's only, I don't know, 30 degrees, 45 degrees, something like that. So it does have that limitation. Well, you can kind of see here, it's that kind of a field of view.
Sure. But when we would use the VLP16s, we would end up throwing away a lot of that data because it was parts of our robot that you know we couldn't. So it might be more useful to target your money for places you actually want to see.
Yeah, and if it's $2,000 is the price point you're talking about, you could, if you did 3 of these cameras, it'd still only be $700 or something. So you can get 3 different angles on it, which would be more than adequate.
But yeah, 2 points on that conversation. You were saying, well, the 16 channel laser is about, would you say, $2,000? Well, I remember when they said, oh, they've reduced the price down to $4,000 now. But when we bought one, we had to pay $8,000 for it because the $2,000 price if you buy 300 at a time. So they'll tell you all these great prices. So probably if you get one for $2,000, you probably have to buy at least 100 of them for that price. And the other point was you were saying that you had to throw out the data because your machine was in the way. That goes back to my argument. Everything wants to be up on top with a clear view of everything. But if you put a GPS in front of it, that blocks your view, and you put a camera in front of it, that blocks the view. So that goes back to my statement. Everything wants to be on top with a clear view.
Yeah.
So it's all trade-offs.
Well, that's what I was thinking about with down the road a little bit. I want an arm, some kind of an arm on my rover that can move, right? A robot arm. And that thing is going to be in front of the camera every time I turn around, right? And that's why I was pointing out those occlusions that I was seeing in the depth camera already with one camera and just me sitting here. Now imagine trying to pick an object with my robot arm. I'm going to have cameras on the sides in order to see where that arm is at. Of course, the arm will know where it's at as well, based on its kinematics. But
could you mount the camera to the arm?
Sure. Yep, that'd be an option too. Yeah.
And that way, you know, the arm won't be in the way, I guess.
Yeah, right. At least wherever, depending how far down you attach it, right? Yeah.
But then that introduces the problem with whatever uncertainty you have with your arm position, that'll propagate to your visual system, which, you know, may or may not be acceptable.
Right. Yeah, depending how you train, right? So if you're off, if you're, you know, if this is the object you're trying to hit, and you're coming in high, if you use some you know, some kind of a machine learning thing to compensate for your errors, you could probably work around that. I guess your arm is more likely to come in low because of gravity, right? But the image recognition should know that it's coming in low and then apply more power to raise the arm in your control loop, right?
How, Alan, from your experience, how hungry is the depth camera processing, at least the pre-processing that you did? Right, like, do you need a GPU to be able to use it at this stage?
No, I don't think so.
Okay.
It didn't seem too bad.
Because LiDAR data wasn't that bad. It'd all come up through Ethernet, and it was on the realm of being bad though. That's the thing. So like if you're going for multiple real sense cameras, like I wonder how your computing requirements would scale.
Let's see here. Can I put that?
Of course, you see zoom at the top.
Yeah, the first two, right? There's your real sense right there.
56%.
And that's
Not terrible.
50%, 56% of one CPU, the way they do that. Because you know Zoom's taking 122%. So it's taking 1.25 cores to run that. It's always confusing trying to look at those, but
Yeah, I was gonna say the same thing. I'm not sure quite what this is saying. I have 16 gigs of RAM total, so that must be what this is.
So it's using about a gig, bit more. Wait, did I do that right?
You're saying that number right there is a gig?
No, I was incorrect.
Do you have HTOP installed?
Do I have HTOP?
actually there's like a control key you can use on top, and then it'll switch those to show you change the numbers. But I don't know what it is right offhand.
It was 262 megs, by the way.
Is that what you were asking about, Matt?
Yeah, it kind of organizes the data a little bit different than top, but
So let's see if I've got, now if I turn that off. I don't know, somebody can look at the, look at the numbers later and figure out what this is. Percent CPU, 20%. That might be a better measurement right there. That was 20% when it was off.
So you said you don't need a GPU, Alan?
Right, I'm not running a GPU. It's just a standard laptop. So whatever it's got in it for a,
Oh, that's much better than the Z camera. Z camera need a GPU. A larger depth camera from Studio Lab.
I know on that T 265 they have, you know, I don't know if you're familiar with these neural compute sticks from Intel. It actually has a neural compute stick built into the stereo camera, so it does a lot of processing on board. But I'm not sure about those the 435.
you know, I remember reading that it does something on board, but I don't remember what.
To me, the depth, this Intel camera reminds me of those Kinects that people would use
Early
a
on.
few years ago.
Yep.
Right? Isn't it basically the same sort of information you're getting?
Yeah, this one's better because it's stereo camera, and the Connect uses like infrared.
Is
They
this
don't
not
work
using
well
infrared?
outside. Just stereo camera.
Oh, that's all stereo camera? Okay. I assumed that there's some.
It's pretty amazing. It's getting better. So what do you think about training deep learning for localization? So we could have a farming deep learning. Oh yeah, right here. So this is SegNet. I'll post the link. I don't know how to do that now, but so it's like a generic training. So whatever environment you're in, it could say, you know, trail, grass, obstacle, sky, or onions or something like that. Just like a generic. And so then your camera just uses segmentation to parse the scene and see your environment.
If you have any training data, then that'd be an interesting exercise.
Like windrows for bailing, or even orchard rows, things like that, that are really standard or really kind of really similar, I guess. I don't think you're going to get 2.5 centimeter accuracy, but that's
It
hard.
all
to do.
depends on, right? If your field of view is, you know, if you're only looking, instead of looking at the whole yard, like that picture you showed was looking at the whole backyard. If I'm a foot away from what I'm filming, then I could get, right. So it's about the plus or minus.
Interesting. Yeah.
But then how do
ahead.
you overcome distortion? Well, I guess if you train on ground truth, then it overcomes it anyways, but.
Yeah, so I'm planning on ultimately being able to pick weeds, kill weeds that are this size or smaller. So it's whatever this size is, but my camera's only going to be whatever that is, 2 feet away from this.
If you had an 8-inch end effector, that may help.
Just demolish it all. A bigger hammer.
Yeah.
So this might be an odd question, but what if you're using that fiducial marker? You got a camera and it's looking for your fiducials, and it can give you the pose of the fiducial out there. What if you had a projector and you projected that image onto something, like, so when Matt's driving through the trees, what if you would project your image onto a tree and have the camera look at it? Would that work? Or is that, I suppose the tree wouldn't be flat, so you wouldn't have a flat image to look at. Maybe you can only do it at night, so it's going to be dark out to project it. But I wonder if anybody's looked into something like that. So that's kind of like the Kinect camera that projects the dot pattern out onto things, and then the infrared camera reads that and makes sense of it. Maybe you could say project these things onto, say, project them on your wall, and then be able to read that with your camera. I've never heard of anybody doing that, but that might be another approach.
I think it's because projectors used to be way more expensive than they are nowadays.
That's interesting. It looks like John Lee got his fiducials working.
Yeah, that's what he's doing, right? He's looking at the ceiling. He's got fiducials on the ceiling, kind of like what Jeff was talking about.
Yeah.
Yeah, that's actually Jeff. I also have similar thoughts about that. But yeah, that's Mark is working, but looks like I could not do the navigation yet. Probably some issue here. Is this an issue? Is this setup met when you are doing the test?
Right now, your fixed frame is your Raspberry Pi camera. And so what you want to see is the fiducials will be stationary, fixed to your map. And then as your robot moves, you can see it moving, and the fiducials will be static.
So you mean I need to change?
Yeah, so each of the fiducials need to be referenced to your map frame.
Yeah, looks like I don't have the map frame established for some reason. Like let's see.
Yeah,
The frame map doesn't exist.
Yeah, so you'll have to kind of like affix, you want to call that, your fiducials in the map frame. And then your robot frame is called your ODOM, and that's attached to your ODOM. So your map frame and your ODOM frame, if you listen to Tuli Foot's talk on transforms, I think it's in ROSCON 2015, he talks about why we use the map frame as your high level, and then you have an ODOM frame for your robot, and then the distance between your ODOM frame and your base link is your robot moving around, and that's the one that moves, is your base link. So you're pretty close in the fact that you've got the SLAM working.
So did I miss something?
No, you just got to kind of extend your transform world. You have to have a map frame, and you have your map has an origin, and then from that origin, there's since your fiducials are fixed in your world, there's a specific distance from your origin to each one of those fiducials. And that's a static transform because those don't change. They're stuck to your wall. And you'll need to put each one of those static transforms in there. So your map frame is your parent frame, and then the fiducial is your child frame. And then you'll use the fiducial SLAM that's from Ubiquity Robotics, and that's kind of what you have running, I think, here. And that you need to calculate the distance from your map frame to your base link. But what we do is we go map, ODOM, and then base link. And for the most part, I cheat a little bit, and I put a static transform between the map frame and the ODOM frame, and that's just there's no distance, no error measurements. But if you listen to the talk from Tuli Foot on transforms at ROSCON, he explains why you'll want to do that. But that's really great. Good job, John.
Oh, thanks, Matt. Yeah, I just want to kind of complete, moving forward, complete this cycle. Basically, with Mark, how can I do the navigation, transfer, this kind of transfer and the navigation?
Yep, you're making progress. So for navigation, you have to have a map frame, and you have to know the distance between where your robot is in reference to the map frame. Looks good.
And just a related note, typically if you start up the navigation package, it creates the map frame and probably associates it to an ODOM frame. So if you're not, I assume you're not running any navigation right now in addition to what you have. You're just, I assume you just have the camera looking at those, is all you're doing right now. So if you're following a demo somewhere, go down the line where they say, here, start up this launch file, and it's going to have all the extra stuff you need to tie all that stuff together.
Yes, I think right now I build the transfer TF and running the fiducial like SNAM load from the Ubiquiti Robotics just.
Well, with that running, if you do a ROS topic list, do you see map, and do you see, let's see, is map a topic or is map a transform? You might have to do the transform tree. If you go back to RViz on the side, it'll say show the transforms, and then you can go down there and you can see which ones are defined right now. Maybe that's what you were showing, and maybe you don't have the map transform or the map transform available at this point. And I haven't gone through that Ubiquiti robot SLAM stuff that you're talking about, so I can't say one way or the other if that's what you need to do.
So it's not showing here, looks like, yeah.
It could be the map is not a top. This is showing your topics. These are messages, where the map is actually a transform. If you can pull up RViz like you had before.
Yeah, I will keep working on that a little bit more. Yeah, thanks.
So if you have RViz up on the left over there, you had something that said like TF101, TF102. Those were the markers in your transform tree for your fiducial markers, And if you have map running, map should show up in that list too. So possibly you don't have that running at this point.
No, you mean the left side?
Yes, on the left side.
You mean the add function, add? Or the pass? No, I don't see that. You mean the TF?
Yes, on RViz it'll say something like TF or transforms or something, and you pull that down, it'll say show the transform tree or show the elements or something. And I thought you had some that said like TF101 and TF102 and so forth. And if you have map available, it should show up under that same list as you pull those down.
Here?
Yeah, so you got frames, it says all enabled. So it's, go down where it says tree and open the one that says tree down there. Expand the entry that says tree.
Yeah, it seems the internet a little bit freezing. Sorry, internet have some issue.
Is there an actual tutorial for what you're trying to do, or does it show you the steps to set this up?
You mean the navigation stack for the?
Yeah, basically the thing you're running right now, where you've got a camera looking for the fiducial markers out there. I just wonder if there was a tutorial that said start this and this and this, and this is what you should see. I just wonder if there's something that documents this to show you what you're supposed to be seeing. And again, I haven't gone through any of this, so I don't know if that exists or where to find it.
There's a navigation tutorials, and then there's a class on the construct on the navigation.
Well, I was just curious if whatever he's starting this, I assume he has a launch file. I just wonder if the launch file is starting up navigation or any of the other, anything else.
It's not right now. He's just
Because you
running.
need something to generate your map. Actually, if you're running the standard SLAM, not the visual SLAM, it will also create your map frame. It creates a blank map and creates all the things together. So, you know, whether or not that's started up, I don't know at this point.
Awesome. Anything else for tonight's meeting? Lee, also check out the Ross channel if you're running into problems. You can post your questions in there, and we can try to point you in the right direction. But
Sure,
good
sure.
work. Good work getting that going. Love the videos.
Thank you, man. Still missing components, missing part.
We all are. Join the club.
Yeah.
All right. You guys have a great week.
Okay, see ya.
Thank you.
Bye-bye.